Good morning, students. So today we are going to discuss about ionic or electrovalent bond and bond parameters. Okay, so these two things we are going to discuss in detail in our fourth unit today. Now first of all, what do we mean by ionic or electrovalent bond? Now see, when a bond is formed by complete transfer of electrons, in this type of bond there is complete transfer of electrons from one atom to the another. Okay, by doing so what happens, their outermost orbits they acquire either 8 electrons or 2 electrons. Okay, 2 electrons in case of small atoms, so we say their duplet is complete, and in case of 8 electrons we say their octet is complete. Now by loss or gain of electrons there is formation of ions. Those ions have electrostatic forces of attraction, and this gives rise to formation of ionic bond or electrovalent bond. Okay, so what we will say, we can define ionic bond or electrovalent bond in this way also, that it is the attractive force between the ions forming an ionic compound. Okay. Now when we are saying that ionic compounds are formed, then on what things it will depend? Okay, first of all, it should be there that how we are getting positive ion and negative ion. So their formation should be thought of first of all, that how easily they can be formed from their neutral atoms. Okay, and once they are formed, then how they will be arranged in the form of crystal lattice. Okay, so these three things are to be taken care of. First, formation of positive ion, second, formation of negative ion, and then their crystal lattice. Okay, so these things are to be taken care of. Now what are the different factors which govern the formation of ionic bond? Just now we discussed formation of positive ion, formation of negative ion, and then arrangement in the form of crystal lattice. Okay, so these three things will come. Now these three things are related with which type of energies? Those we will be discussing in this. Now the formation of positive ion involves ionization. Okay, means when we are having this neutral atom and this positive ion is formed, then what is happening there? So when positive ion is formed, then it means there is loss of electron from a neutral atom, and according to the definition of ionization enthalpy, we will say that this process needs ionization enthalpy, or there is the role of ionization enthalpy. Similarly, when we talk about formation of negative ion, formation of negative ion means there is addition of electron. Now addition of electron, that process involves electron gain enthalpy. Now once these ions are formed, positive ion or negative ion, then those ions will combine and they will form a crystal lattice. Okay, so these three things involve three factors. First is ionization enthalpy, second is electron gain enthalpy, and third is lattice enthalpy. Now we will see how these three things play their role. Okay, first of all, ionization enthalpy. Now see, this is that energy which is to be provided. So if we have to provide some energy, then if we have to provide less energy, then it means it is good for us. Okay, so what is known to us now? It is clear that lesser the ionization enthalpy, easier will be the removal of an electron. So it means positive ion formation will be easier, and there will be more chances of formation of an ionic bond. So we have to choose such atom for which ionization enthalpy values are low. Now for which elements these are low? When we talk about alkali metals, then ionization enthalpy values are low. Okay, so they can form positive ions very easily. So what we will say? We will say that the positive ion must be formed from alkali metals. Okay, in case It can be formed from other elements also, but we are saying here for which it will be the easiest. It will be the easiest for alkali metals. Okay. Now second thing, electron gain enthalpy. Now see, higher is the negative electron gain enthalpy, more affinity for incoming electron will be there, and more will be the energy released, and stability of the negative ion will be more. So what do we mean now here? We mean now here that electron gain enthalpy value should be highly negative. If there is high negative value of electron gain enthalpy, then the energy released will be more, and if a particular substance or if a particular system loses more energy, then it means it becomes more stable. Okay. So delta Heg value means electron gain enthalpy value should be very high, and it should be highly negative. More negative means more energy is released. Okay. Now for which particular elements this value is high? For halogens this value is high. Okay. So if we want to make a particular ionic compound, then it means we should take halogens. They will be having highest negative electron gain enthalpy values. Now let us come to lattice enthalpy. Now see, this equation shows the formation of crystal lattice. We have taken 1 mole of positive ion, 1 mole of negative ion, and they are combining to form 1 mole of an ionic salt. Now during this process there is some released energy. So that released energy is known as lattice enthalpy. In case we see the reverse, that if I have to break down a particular crystal lattice into its own ions, then we need some energy. That energy is also equal to lattice enthalpy. Okay. So what can we say? That in the formation of ionic compound, the positively charged ions combine with negatively charged ions to form a compound. The energy released when the requisite number of gaseous positive and negative ions combine to form 1 mole of ionic compound is called lattice enthalpy. So in this equation we can write like this also. Okay, Le stands for lattice and enthalpy. Okay, so this also plays important role. So these three energies play their important role. Now let us see the structure of sodium chloride. So sodium chloride crystal lattice, this structure is also known as rock salt structure. This is also called rock salt structure. In this, small atoms, they represent sodium, and the bigger atom represents chloride ion. Okay. So they are arranged in this fashion, the way you are able to see. Okay. Now how these things play their role, this is what we are going to discuss now. Now see, in ionic solids, sum of the electron gain enthalpy and ionization enthalpy may be positive, but still the crystal structure gets stabilized. Why it gets stabilized? Due to energy released in the formation of crystal lattice. Now what does it mean? It means that lattice enthalpy value was very high. Since lattice enthalpy value was very high, so there was less effect of positive value of sum of the delta Heg and IE values. Okay. So ultimately what should be there? Ultimately, if there is release of energy, when we sum all these three energies and then we get negative value of total energy, then it means that that particular ionic compound is possible and that will be formed. Okay. Now see, we will understand it with one example. For example, if we are going to form NaCl, okay. Now when we formed Na positive ion, then this much was the energy required. Okay. Now when we formed Cl negative ion, then this much was the energy released. So if we see, sum of the energies is positive. Okay. And for making a stable ionic compound, the total energy should be negative. Now if we see the lattice enthalpy value, then lattice enthalpy value is highly negative. Now if we do the total will be 147.1 plus minus 788, then again the total will be negative value. So what does it mean? It means ionization enthalpy plus electron gain enthalpy plus lattice enthalpy is equal to negative value of energy. So since total energy value is negative, so it means energy is reduced overall, and so the compound formed is more stable. Okay. Now thus a qualitative measure of the stability of an ionic compound is provided by its enthalpy of lattice formation, and not simply by achieving octet of the electrons around the ionic species in gaseous state. So what does it mean? It means that if we are simply making 8 electrons in the outermost shell of the combining atoms, then that will not make it stable. But what will make it stable? The lattice enthalpy plays its role. Okay, that is very much responsible for the formation of stable compound. Now we come to bond parameters. Bond parameters means whenever there is formation of certain bond, then which all things come along with that. So whenever there is formation of bond, there comes bond length, there comes bond angle, there comes bond enthalpy, then comes bond order, and then it comes resonance. Okay. So now in this particular topic we are going to discuss bond length, bond angle, bond enthalpy, and bond order. Resonance we will discuss in more detail, so we will discuss it separately. Okay. Now first of all, bond length. What is bond length? The equilibrium distance between the centers of the nuclei of the two bonded atoms is known as bond length. Now here we will talk about covalent radius and van der Waals radius. Okay. Now see how this particular bond length depends on different factors. So it is affected by size of atom, multiplicity of bond, and type of hybridization. Hybridization is the topic which we will be discussing in this chapter only. It will come after 1 or 2 sessions. Okay. So first of all, size of the atom. Now we know what is bond length. It is the internuclear distance between the two bonded atoms. Now if the size of the atom is more, then it means bond length will be more. Just like if I compare the size of fluorine with size of iodine, then size of fluorine is small and size of iodine is too much. So it means the HI bond length will be maximum, or it will be more as compared to HF. Okay. Then comes to multiplicity of bond. Multiplicity of bond means whether there is single bond, double bond, or triple bond. Now see, bond itself means attractive force. So if there is only single bond, then it means there is single attractive force. If there is double bond, then double attractive force. If there are triple bonds, then there is 3 times attractive force. So it means attractive force brings the atoms together. So it means if force is more, then atoms will be more nearer and the bond length will be less. So least bond length is in the case of triple bond and maximum is in the case of single bond if we compare the same bonded atoms. Okay. Now similarly, type of hybridization. Okay. Now see, here we have to remember greater is the s character, shorter is the hybrid orbital, and hence shorter is the bond length. Now how to find this s character? Now see, there are so many types of hybridizations, but here we will be discussing about sp3, sp2 and sp hybridization. Now see, sp3 means one s orbital and 3 p orbitals have combined. So total orbitals combined are 4. So if I want to check s character, then just like we calculate percentage, we have to calculate here. So s character for sp3 will be, since there is total 1 s orbital and total orbitals are 4, so 1 divided by 4 into 100, so percentage comes out to be 25%. For sp2 total orbitals are 3, so 1 by 3 multiplied by 100 means 33.3%. For sp there are total 2 orbitals, so 1 by 2 is equal to 50%. Okay, so it means that S character is maximum in case of sp hybridization, and what we have studied, greater is the S character, shorter is the bond length. So S character is maximum in sp hybridization, so it will have shortest bond length. Okay, so these are the factors which affect bond length. Now comes to bond angle. Okay, now see, if we take this water molecule, then in water molecule two hydrogen atoms are bonded with one oxygen atom, and in this way their octet is complete, their duplet is complete, and its octet is complete. Okay, now what is bond angle? When we represent the internuclear distance by a particular line, then the angle between the lines, okay, angle between the lines which represent the direction of the bond, okay, that angle is called bond angle. Now in this case, in case of H2O, bond angle value is 104.5 degree, 104.5 degree, or to be exact 104.45 degree, and this is bond length. OH bond length is 95.84 picometer. Okay, now let us come to bond enthalpy. What is bond enthalpy and what are different factors which affect it? So bond enthalpy, amount of energy required to break 1 mole of bonds of a particular type so as to separate them into gaseous atoms, is called bond dissociation enthalpy, or simply bond enthalpy. Okay, now see what is there. Now we have to take first 1 mole of a molecule, okay, in which there is bond. Okay, now the energy which is required to separate these atoms which are bonded into gaseous state atoms, that energy is called bond dissociation energy or bond energy. Now bond energy depends on 3 factors: size of atom, multiplicity of bonds, number of lone pairs. Okay, now see, in this what we have to do, in simple wording, if we say, we have to break a bond. Okay, and for that whatever energy is required, that is called bond energy or bond enthalpy. Now if the size of atom is larger, then what will happen? Attractive force of nucleus will be less, so it means energy required to break it will be less. So what we will say, greater is the bond length, lesser will be the bond dissociation enthalpy. Okay, similarly multiplicity of bond, if there is just single bond and we have to break it, then it needs less energy. If there is double bond, then it needs more energy. If there is triple bond, then it means further more energy. So it means if multiplicity of bonds increases, then bond enthalpy value also increases. Okay, now number of lone pairs of electrons present. Now see, if there are so many lone pairs present, then what they will do? They will repel each other. There will be repulsive forces. If there are repulsive forces, then the molecule or atom or that particular bond will be less stable. So it means with less energy that will dissociate. So it means if there is presence of lone pairs of electrons, then it destabilizes the molecule and it helps in reduction of or reducing the value of bond enthalpy. Now it comes to bond order. Okay, now see, bond order simply means number of bonds. In simple wording, if we will say, bond order tells us about the number of bonds between the two bonded atoms. Now if we take hydrogen molecule, there is just one bond. In case of oxygen, there are 2 bonds. In case of nitrogen, there are 3 bonds. In case of carbon monoxide also, there are 3 bonds. So what does it mean? Bond order values are equal to number of bonds. Now if there is increase in bond order, then bond enthalpy will also increase. Why? Because bond length will decrease. Okay. Now one more thing which you can remember is isoelectronic molecules or ions have identical bond orders. If two such species are given to us which have similar number of electrons, then we will say they are isoelectronic. And if we know the bond order of one, then we know the bond order of second. Okay, so what is the point to be remembered? In case of isoelectronic ions, the bond order values are same. Now, whatever we have discussed today, you have to go through it and you have to solve these home assignments. Okay, thank you.